Carefully use the space of your drawing sheet. Okay. So carefully use your space. Now I am drawing it here. So I will conveniently use the space. Left side I use the space. So this is draw a 2H pencil and draw a horizontal line parallel to the reference layout line. So this is the horizontal line, 2H line. So to this horizontal line, I have to construct a square. So square, you know, you can be able to construct. Perfect square I can construct. Like this I can construct. So like this, see, it is equally inclined. All the sides are equally inclined to the horizontal. They are 45 degree inclined. All the sides are. This one will be regularly using in your exercises. How you to construct this square? Using your draft principle. Directly you can use your drafter, directly you can construct it. How you can construct it? You can bring your drafter. What you can do? What is this angle? 45 degree. So you tilt your drafter 45 degree, accounting your error, zero error. Right. So 45 degree, once I am tilting my drafter, one scale, what will happen to another scale? That also, how much degree it will be tilted? So two scales of 90 degree. Okay, exactly 90 degree. One scale if I tilt it to 45 degree, the another smaller scale also will be tilted 45 degree to the horizontal. Okay, I can use both these scales. Okay, I can use both these scales. I can draw. Once I have tilted the drafter to 45 degree, I can draw using a horizontal scale that is tilted 45 degrees. Another scale. Using another scale. So this is how the drafter will be. So using this drafter, in the drafter itself I have the values. Okay, that is what is the size of the square? It is 40. So in the drafter itself I can mark 40. So in the drafter itself using this scale I can mark 40. So I can draw the two lines like this. What I can do to finish the other two lines? Anybody? In this fixing I can fix it. So I need to get a parallel line to this. I need to get a parallel line to this. What I can do? I can move my drafter on the same setting. I can move my drafter on the same setting. I can move my drafter from here to here. I can move my drafter. I can draw a parallel line on the same setting of the drafter. The smaller scale I can move I can move it to this location. I can draw a line like this. So I can get a perfect square, inclined square. Do it quickly, please. See the video if you want, you can see. I have a video. See. I'm drawing a horizontal line. Okay. Once I have set to the reference layout line, I'm drawing a horizontal line. Drop it, you see, I'm setting it to 45 degree. Okay. Just a single setting in my draft of 45 degree, I can finish off this square. 45 degree I am setting. See, it is 45 degree. So 45 degree in the sense it is 44, in between 44 and 46. You don't have exactly 45. In between 44 and 46, I can fix 45 degree. So the two of my drafters will measure 45 degree drafter scale. Do it. Quickly do it. We don't have time. Quickly do it. Square and finish it. See, I'm drawing on the same setting. I can use my drafter, both the scales of the drafter to draw the square. See here, using that setting I have drawn two sides of my square. Then I can move on the same setting I can move my drafter. I can draw a parallel line to this. I can draw a parallel line to that. Then, so the line it is a square, you use your H pencil. Horizontal line is a reference line, that is 2H. That is not a 2H. Okay, baseline, that is a reference line. That is 2H line. 2H line, it is a line. You set your drafter to 45 degree. Okay, the drafter I will have like this. So small scale and a bigger scale. 45 degree. Right. This is 45 degree. Right. The two scales of my drafter, using that I can draw 40 mm, 40 mm. Exactly in my drafter itself I can mark it. On the same setting I can move my drafter to this end. Right. So draw a parallel line. Again for 40. Right. The same smaller scale. Parallel to the smaller scale I can move it here. The same smaller scale. I can draw a square. Perfect inclined square I can draw it like this. Right. You have any intermediate friend? This is a geometry we need. I can draw it using my 2H pencil. I can H pencil. So any color chalk I am using, that is H pencil. Any white chalk I am using, that is 2H pencil. Remember that? Any white chalk I am using, that is 2H pencil. What is the data in my problem? It is given a small problem, that is it is side of the square is 40 mm. That you have to dimension it. Listen, that you have to dimension it on the same setting. Okay, any one side you can dimension it and you can show it. Okay, this is the side I am going to dimension. So keep your drafter one scale to this. Another scale will be perpendicular. Using that, draw an extension line. Drawing extension line here, leaving 2 mm gap. Right. You set your drafter scale to one side, which you are going to dimension. The another scale will be perpendicular. Using that, I can draw an extension line. So you have to use your drafter for drawing extension line by fixing a scale to the geometry which you are dimensioning, the entity which you are dimensioning. Right. So using that, I am drawing a perpendicular extension line. So then, on which scale you have fixed the geometry you are using that scale of your drafter, I can move it 10 mm away and I can draw a parallel line. I can draw a parallel line, that is called dimension line. So this extension line and dimension line, you have to use your drafter. It is into, see, this is white, it is 2H. I mean, you no need to ask. If it is in white color, that is 2H. Right. Yellow color, that is an H pencil. Right. So this gap you have to maintain it 10 mm gap. So then you dimension, put the arrow head as small as possible, maintaining 1:3 ratio. In between extension lines. See here. Listen. Come in. Listen. The dimension value 40 you have to insert it. Since it is an inclined dimension, how I have to write it? Horizontally I have to write it. Right, you insert it. So this is 40 and the writing should be horizontal. The writing should be horizontal. It is unidirectional. The writing should be unidirectional. Is it clear? Now we carefully put the arrowhead. I will correct the arrowhead otherwise. Right? As small as we put the arrowhead, it should maintain the 1:3 ratio. So the length of the arrowhead can be 5 mm. The height of the arrowhead will be 1.5 mm. That small you have to put 1.5 mm to 5 mm. Right? Is it clear? The size of the arrowhead, it should be 1.5 mm to 2 mm. The length of the arrowhead will be 5 to 6 mm. That is the maximum for your drawing sheet size. Is it clear? Okay. Right. Read fast. Construct a pentagon of size pentagon of side, regular pentagon of side 30 mm, 30, regular pentagon of side 30 mm in such a way that subdivision 1, a side of a pentagon is horizontal, a side of a pentagon is horizontal. Subdivision 2, a side of a pentagon is vertical. So I have 5 sides in my pentagon. In that one side, if it is horizontal, how will be the pentagon? So one side is vertical, how will be the pentagon? Right? So the 2 pentagons you have to draw. You see here, pentagon how I can construct? So what? The pentagon is having 5 sides. Okay. So I can draw one side of my pentagon like this. So this is 30 mm, this is horizontal. Right? Listen all of you. One side is horizontal, this is 30 mm. Right? Then the other side I have to draw it like this. So what will be this angle? 72. How it is 72? 360 degree divided by 5 sides. So that is an angle. So this angle will be 72 degree. Can you tell me what will be this angle? 90 minus 72 will be 80 degree. Right. So what you can do to draw this line, either I can use 18 degree or 72 degree. So I will have my drafter perfectly 90 degree. 2 scales perfectly 90 degree. I can have my drafter here. Either I can move this vertical scale of my drafter to what? Degree? 18 degree, or my horizontal scale to 72 degree. This is convenient for you, you can use it. Right. So once you have set to 18 degree, using that scale I can draw my other side. Listen. Similarly this side, this is 72 degree. This one is 72 degree. Outside angle is 72. So what will be this angle? 18 degree. So I can have my drafter here. Drafter will be like this. The vertical scale I can tilt it to 18 degree to the negative side. So this side I can tilt 18 degree. Right. So using that scale I can draw this line. So on this, using that scale itself I can mark my measurement of 30 mm. Using that scale itself I can mark the measurement 30 mm. So I have got the 3 sides. So what I can do? So I have got 3 sides. So this is the one side, the other side. I have it like this. So this is 30. Right. I have got 3 sides. How can I get another corner? Any easy procedure you have? The other corner how I can get? Pentagon. You measure the 30 mm in your compass. What I can do? 30 mm in your compass, from where I can cut? From here I can cut a 30 mm, or from this end I can cut a 30 mm mark, I will get another corner. So from here 30 mm mark, cut it from here. So the intersection will give me the another corner. This is my pentagon. So this is the easiest way of constructing a pentagon. You have so many methods to construct a pentagon. Okay, these are all comes from a center, circle. So circle is, it is an infinite polygon. Okay, so inside a circle if I draw equal sides of 5 sides, so that will be a pentagon. If 6 sides, if I don't know, it is inscribed hexagon, okay, octagon, okay. The circle is a infinite polygon. So inside a circle I can draw pentagons, outside polygons. Outside the circle I can draw polygons. Okay, these are all comes from a circle. So remember that this is the way I can draw. One side is horizontal, I can draw a pentagon like this. Using my drafter I can construct 3 sides. Using my compass I can construct another 2 sides. Right. So then you can dimensionate this side. So fix your drafter parallel to this, then extension line, then draw dimension line like this. Then this is the 30. Right. The vertical pentagon how I can construct? I can draw a vertical line like this, 30 mm. Then I have to construct and so my drafter will be like this now. What I can do? Using drafter scale, either this is 72 degree or so the same drafter scale 80 degree I can move it here so that I can get that incline another side. So this side I can get it by tilting my drafter 18 degrees. This side I can get it by tilting my drafter another 18 degrees. Then from here I can have an arcs, two arcs. I can construct a pentagon. This you can do it now. Right? So you can do this. Then we move on to the hexagon, how to construct a hexagon. So pentagon, I have the video that you can see how to construct a regular hexagon. So I can have a hexagon. So hexagon, the easiest way of constructing hexagon, because why the easiest way I am going? So regularly you will be using the square, pentagon, hexagons in your further exercises. Okay. So once it is a pentagon or hexagon, quickly you have to draw it within 2 minutes. You are able to draw pentagon, hexagon, square within 2 minutes. Okay, you should not take time in drawing the regular polygons, right? So hexagon, how I can draw? The easiest way of hexagon, suppose you take a problem for hexagon, draw a hexagon. The same problem you take it. One side is, instead of pentagon, it is hexagon. The same problem you take it, instead of pentagon, it is hexagon of 30 mm side. So how I can construct? So I have to draw a circle of radius equal to the size of the hexagon. Of radius equal to the size of this hexagon. This is a circle I am drawing. Is it a construction work or what I want? I want a hexagon. The circle I am going to draw, that is a construction work. You have to use a 2H pencil. See, you can have a radius of the circle equal to the side of the hexagon. See, 30 mm radius I am measuring. So I am drawing a circle of radius 30 mm. Right. So this is my center. The radius is 30 equal to the side of the hexagon. Right. Now, suppose I want a side of a hexagon. So I want a hexagon like this. So you see, two sides, not one side, two sides are horizontal. If I draw it in a vertical manner, two sides are vertical. How I can get this kind of hexagon? Listen. How I can get this kind of hexagon? You see, these corners I can keep it on my circle. This corner I can keep it on my circle. What I can do? I can draw an axis line. Listen. So these corners I can have it on my circle. It is going to be on the circle. So all the corners are going to be on the circle only, right? So these corners, what I can do? I can have it as an axis line. So to get this, I can draw a horizontal axis line. This is also a construction line. You need not draw all the way the line. So you can keep your drafter, just you can mark this. This students only to getting these corners is my intention, right? So once you have got this as an axis, right? So using from this corner, I can get the other corners. What I can do? Compass, measure 30 mm in your compass. What you have already to draw the circle, that measure when using this, I can cut here, cut here. I will get two more corners. The same radius from here I can cut again in the bottom. I will get another two more corners. By joining this all six, I will get a hexagon. So these are all constructions. The hexagon alone should be the use your H pencil. So the same way, the second subdivision, how I can draw it? The same circle, the axis line, how I have to construct? Vertically I have to construct, you have to finish it out. Right? Can you do it? Right? Is it clear? The other one, construction of a regular polygon. Construction of a regular polygon. polygon I can construct it. See, suppose I have 9 sides of polygon. I have 9 sides of polygon. Right. How I can construct that? You see geometries, right? So suppose I have 9 sides of polygon. How I can construct? Just to make a note in your drawing sheet, in your notebook, right? Say side of 30 mm. I have a side of 30 mm. I have to construct 7 sides polygon. Right. So see here, 9 sides polygon I am going to construct. So I can take this side, say this is 30 mm suppose. What I can do, using this as a radius, this as center, I can draw an construction circle. I can draw a construction circle. So I am not going to finish full circle, it is a semicircle. I can finish a semicircle like this. What I can do, how many sides you are going to have? 9 sides you want in your polygon. So what you have to do, what is this angle? 180 degree. So this 180 degree you have to divide it into 9 equal segments. So 9, if I divide it into equally 9, 20 degree each. So 20 degree each. So I can have it 20 degree each. This is 20 degree. This is 20 degree. 9 divisions I have. This is my first division. Nine divisions I have. 9 segments I have. So each are 20 degree. So each divisions are 20 degrees. Right. So what you have to do, from where you have to start? So from the second division you have to start. Whatever be the polygon size, okay, number of sides, the second divisions you have to start. So this is my first side and this is going to be my second side. So from here I have to start. What I can do is, so I can draw a construction line to the third division. But now what I can do? 30 mm you can measure what you have in your compass. From the second division you have to start in and you have to cut it here on this construction line. Right. So this will give me the third side. Right. Going to the fourth side, what I can do? The fourth division, I can draw a construction line through the fourth division. Through the fourth division. From third to fourth, the same 30 degree I can cut it here. So I will end up like this. So same fashion, if I finish it, I will get a regular drawing board. You know, as I should what you are sitting, it's a drawing board, right? A separate drawing board also you have. You can buy it and you can have it in your home, right? Suppose you want to do exercises, okay, you can have it in home. Okay, drawing board, that is the top one alone you will get it. Okay, drawing board, you have standard drawing board sizes available, right? So what is this size? You can buy it, right? If you want. Then drawing clips, you open the clips, you have 4 clips with you, right? The clips you can see. You can see the clip. Okay, clips like you have a bent portion and a flat portion, right? So remember that the bent portion should not come on the top of your drawing table. The bent portion has to go below the drawing table. The flat portion of the clip has to come on the over the top table. How to fix? See the video. See the video. The drawing table is, listen, see the video, the drawing table is very rough. So how I am going to fix the drawing sheet in your drawing table? You see right bottom corner, already I had a backup sheet. Okay, you have your drawing sheet already filled with layout and title block. So I am keeping it over the backup sheet on the right bottom corner of your drawing table. Right, you see the periphery of the drawing sheet which you are fixing, it has to match your right bottom corner. Right, is it clear? So it has to exactly match with the right bottom corner of your drawing table with the backup sheet. Then you take your clip, you see the clip. Clip, you see you have a bent portion and a flat portion in the clip. Okay, the bent, how I am fixing, you look at the video. See, the bent portion should not come on the top. See, I am fixing it in a wrong manner, first of all. So you should not do that. The clip, how I am fixing. Okay, this is a wrong one. So you keep your flat portion of the clip on the top. Okay, remove the clip and you keep the flat portion of the over the top, right? So if you have a drawing sheet, empty drawing sheet, use it as a backup sheet today, right? So exactly the drawing sheet has to match with the periphery of the drawing table, and the drawing sheet should be filled with the title block and layout. Okay, that is, you have to draw it separately. You see the other clip, I am fixing it in the bottom. You see the other clip, I am fixing it in the bottom corner, right corner, right. The one more clip, I am fixing it to the left of my drawing sheet, left bottom corner of the drawing sheet, right. See the video? Right. So you see the one more corner of my drawing sheet is open. Okay, how I can use my clip there? So that corner, if you are bringing a rolled sheet, that rolled sheet keep on rolling while you are drawing your drawing. So what I have to do, I need a cellophane tape to fix that free corner of my drawing sheet. So is it clear? Can you see the video? The one more corner to be fixed using a cellophane tape. Right, neatly a small strip of cellophane tape, you pick it and fix it. Right, that's enough. Otherwise, while removing the sheet, carefully you fix it. And the pencils and all, you can keep it in the drawing table. You have provisions for keeping pencils, your instruments. Right. Is it clear? Fixing of drawing sheets, you have any doubt? You have to fix to the right bottom corner. Okay, the periphery of the drawing sheet has to match with the periphery of the table. Right. With the back sheet, you have to keep your drawing sheet over that which is the drawing sheet. It is filled with the title block and the layout. So the next instrument, you have protractor, French curves and set squares with you. Right. So what is the use of protractor? You know, I can use it angular. Measurements I can take it. Right. You have set squares. You have set squares, two set squares with you. So one set square is exactly 45 degree. Okay. 45 degree set square you have. So 45 degree line, if you want to draw it, I can use the 45 degree set square. Right. So one more set square you have. It will have 30 degree and 60 degree values in another set square. So using that set square, I can draw 30 degree line and 60 degree line. So my set square, using my two set squares, I can draw 30 degree lines for 60 degree lines and 45 degree lines. Right. So one set square is fully meant for 45 degree. Another one set square I can use it for 30 degree and 60 degree. So then here. See here, this is exactly 45 degree. Right. This is exactly 45 degree. This line, using this I put, it is a 45 degree line. It is a 45 degree line it will give. Right. So the another set square you will see. So what is this angle? 60 degree. This is 60 degree. This will be 30 degree. So if I want 30 degree like this, I can turn it like this and I can use it. 30 degree and 60 degree. Right. So this is used. You are not going to use it here in your class. You will be using your drafter for angular measurements. This will be useful in your home. Right? So in your home, suppose you don't have table, you are not able to fix your drafters and all, you can your normal table, you can use this and you can draw it. Right? Because mostly you will be having 30, 45 degrees, 60 degrees, right? So if you don't have a provision, you can go for it. Here, you can keep it away. Right? University you will be using only drafter. So inside this set square, I have a curve like this, that is called French curve. That you can use it for drawing a freehand curve. Freehand curve, suppose you want to draw it, at an orientation of this I can use it, okay. And I can draw free curves using that French curve. Okay. Then go to the instrument box, you open your instrument box. So in the instrument box you have all the things you see. Look at the instrument box, a compass is there. Okay, it is not an ordinary compass, right? What you had an ordinary compass in your geometry box, okay, that is an erratic one. This is a more accurate one, so that's why it is used in your drawing purpose, right? So in your compass you have a small compass that is used for, that is bow compass also you have. That is used for dividing purpose also it can be used, right? Then you have small compass ends you have, that is just a scriber like thing you have. Then you have one more attachment, you can instead of pencil lead, I can use another more attachment that is used for, you can fix a micro tip using that, okay? Compass level, the one thing end, I can remove it and I can fix a micro tip holder there, then I can use my micro tip for my compass, right? If you want. Then I have a screwdriver in that, a plate like thing you have. That is a screwdriver, anything you want to tighten it in your instrument box, you can add, the screws you want to tighten, you can use that screwdriver, right? Then you have a small box, inside you have leads, right? That leads you can use it if your lead is worn out in your instrument, that is compass, right? You have a large compass and you have a short compass, that is called bow compass, right? So in that bow compass and large compass, the lead portion I can remove it. I have a small metal attachment in a lead portion which I have a lead, that I can remove it and I can fix a metal portion there also. Okay, you have a metal, separate metal thing I have. See, this one I can attach it in my large compass by removing the pencil portion, lead portion, and this one I can attach it in my bow compass removing the pencil portion. So the two ends of my compass, large compass and bow compass, will be a sharp powder like sharp metal pointer like this that can be used for dividing purpose. That is termed as divider. If I don't have legs, then it will be a divider. Right. So you see, I have a video to show. You can see the instrument box. Look at this is a protractor, and I have standard circles to draw. I have one more thing you have with you like this. Okay, the standard protractor, it is for 360 degree I can draw it. So I have standard holes in even numbers. Okay, you can use it if you want. This will be useful in both. Right. Then I have a 45 degree set square. Then I have a 60 degree, that is 60 and 30 degree set square with you. Right. So in 60 and 30 degree set square, you have a French curve inside. That is used for drawing a freehand curve. Right. So without French curve, you can draw it. Through your skill, you can draw a freehand curve. Right. That is very good. So without using French curve, drawing it through freehand curve, so better. Right. Then you can have an instrument box. Okay. You have an instrument box. So in the instrument box, so you have screwdriver, you have bow compass. So bow compass in the sense I have a bow to that dog, right? So it is fixed. The bow compass, okay, the large compass is the screwdriver. Just now I am showing screwdriver in that. Then the bow compass I have. The bow compass you can see. So I can adjust this radius. This radius is fixed, I can fix it. So the constant radius I can use it for any measurement. Right. So it is using a spring. This is called bow. Right. So this attachment I can remove it in by compass also. I have a large compass. The large compass in the large compass. You can see. You can take it and see the large compass. How the pencil is kept in your large compass. That is the fashion. You have to sharpen your pencil. So normally you should not sharpen it. Just one corner you have to sharpen it. So one taper like thing you will have in your pencil. Okay. As if now what you have in your pencil, how it is sharpened, that is the right one. You have to sharpen your legs like that. Then you see the large compass, I can extend it. So for drawing larger radius, arcs or circles, I can flip this end of my lead. Okay. So I can use it so easily I can draw it. Okay. So carefully you tighten the nuts and all, right? Then that portion which I am flipping it, that I can remove it out. So I can insert in another. So instead of that, so you have a small screw and right, a small bolt like thing I have, that I can remove it and I can fix my, what is that? Micro tip holder I will fix it. Carefully you can remove it. How I am removing, you see. I have removed. Put and screw and nut I have removed. That portion I have removed and I can fix my micro tip holder inside and you can insert your screw and you can using the nut you can tighten. Right? Is it clear?
to the left, top left corner
Okay, not exactly to the corner. You have to leave a space and you have to fix it. You see the video, so it will be more clear for you. Carefully you see the video. Fixing a drafter. Okay. So you're fixing a drafter. How to fix it? You see the video. So the drafter, my drafter you can see, this is a longer scale, horizontal scale. This is a vertical scale. So both are perpendicular to each other. Okay. In a drafter what we have? A longer and vertical scale. Then you see inside there is a grating, there is a protractor. Okay. Then in that metal plate I had a marker. Okay. Is it clear? See again. You see in a drafter this is a vertical scale. Then in the middle I have a protractor graduations. Right. Then I have a marking in the plate, blue plate. So that is the what you have to see. Right. When you see the marking, then the other end, that is nothing but the holder. Okay. That holder you have to fix it. Rigidly you have to fix it on the table. Right. That holder, you see that holder which I am doing, inside I have a plate, flat portion. That flat portion has to be exactly matched with the flat portion of your drawing table. You see how I am fixing to the left extreme. To the left extreme, you should not fix to the left extreme. You have to leave a gap. That fit gap you have to leave it. You see. Then you have to fix your drafter. How I am fixing, you see. Then you have to fix your drafter. You see. This is a wrong one. You should not have any gap. Come down, gap you see. You see. There should not be any gap in the fixing of your drafter. This is very much essential. That gap you should avoid. Carefully that flat portion you rigidly fix it with the flat portion of your table. Right. Carefully you watch. There should not be any gap in the holder with the table. If you find gap in the holder and the table, then you will find error in your drafting usage. Right, is it clear? So fix the drafter rigidly to the table. Fix it quickly with my horizontal scale. I can draw a vertical line, perpendicular line. I can draw parallel lines to any line. Any inclined line I can draw parallel lines. So I can draw any inclined line. I have protractor graduations in the middle. Right. So over that blue plate I have a grading, okay, marking, okay, that will define the angular orientation. Right. Now what you are going to do, you move your drafter's horizontal scale and align it to your top layout line what you have drawn. That layout line what you have drawn manually, that is going to be your reference. That's why you have to fix your drawing sheet carefully in a perfect manner, right? So you move your drafter to the layout line, horizontal scale of your drafter. Drafter you have scale, horizontal scale, that is a lengthiest scale. Then you move it to the top layout line and fix the knob. Align to the top layout line and fix your drafter. You see the video if you have any doubt. See here, zero setting and usage of drafter. Okay, so what is zero setting? We will see. You see the drafter, see this video. Carefully watch the video. What I am doing, I am setting my horizontal scale of my drafter to the top layout line. That is the reference line I am going to use. Right. I am tightening the knob of my drafter. Right. Now you look at the grading in the blue plate and the graduation in the protractor. So that two, so I am doing it, that two has to match exactly grading and the 0 degree has to match. If it is perfectly matching, you are fixing off your paper and you are fixing off your drafter and your drawing table, everything is perfect. Right? So your drawing table is perfect, you are fixing off drafter is perfect, you are fixing off drawing sheet is perfect, you are fixing off your drafter and your drawing table, everything is perfect. Right? So your drawing table is perfect, you are fixing off drafter is perfect, you are fixing off drawing sheet is perfect. If the grading and your drawn layout line is perfect and your cutting of your drawing sheet is perfect, the A3 sheet how it is cut, that is perfect. Okay, everything if it's perfect, That grading and the 0 will match exactly. There will not be any error in 0 and the grading, right? So that is called, if definitely you will have error. Definitely you will have error from 0 to 2 degree. Okay, each grading in my protractor is 2 degree. You see, look at your drafter. Each grading is 2 degree, right? So in between 0 to 2 degree, I will have an error definitely. Why? Because the drawing sheet it is not cut properly. So the layout line what you have drawn, it can have an error. The drafter how you have fixed it may have a small bit of error. The paper how you have fixed it may have a small bit of error. This all together it is get accumulated and it will be coming into your 0 error. Right? So that 0 error you have to take it into account while you have doing any measurements. Any angular measurements if you are using, that 0 error it should be accounted. Carefully accounted. If the 0 error is coming in the negative side, I have to use it. Positive angle if I am measuring, that you have to minus it. If in a negative angle I am measuring, that you have to add it. Okay, carefully that the 0 error has to be accounted. You see the video. So just I am playing here. You see, now it is having an error, 0 error of 1 degree. Okay, in between 0 and 2 I have the grading in my fixing. So that is a 1 degree of negative error I have in my drafter. See, using that horizontal scale I am drawing a line, that is a horizontal line parallel to the layout line. Right? Parallel to the layout line. Then using a vertical scale I have drawn a vertical line that is perpendicular to the horizontal line, that is a perpendicular line. So the line to this one. Okay, parallel line to this vertical one. So the backwards I can get a parallel lines wherever I move. The vertical scale I will get vertical lines wherever I move. So that vertical line. Right. So if I want an angular of 30 degree, you see, the drafter I am now opening, so I have to draw a 30 degree line here like this. Okay. So drafter on a horizontal scale, I am rotating to which angle I have to set. Already had minus 1 degree, which angle I have to set? 31 degree. I have to set 31 degree, then only I will get a perfect 30 degree. In my setting of my drafter, I have to set 31 degree, then I can get, using that drafter scale, I can draw a 30 degree line conveniently. Right? See, that is a 30 degree line. Now, suppose I want to draw a 30 degree line, like this, the same drafter I have to tilt it 30 degree to the negative side. What I have to do? I move it. What angle I have to set? 29 I have to set, because I had a negative 1 degree error, right? But this is 30 degree I will be getting. So this is the thing that my 0 error, compensation of 0 error, right? scale of drawing. You see, scale of drawing. It is not the scale what you have. It is a drawn size to an actual size. Okay. That is the scale of any engineering drawing sheet. If you see, there will be a scale. There will be scale written over the title block. Okay. Depends on the size of the component for which you are drawing the drawing. So you can see the scale. It is the ratio between the drawn size to an actual size. The scale, I can write it. The scale. You should remember this always. It is drawn size by actual size. Scale, I have different scales. Full size scale. The full size scale, you know, suppose you have the component. Okay. Suppose you have the component which can be drawn in your drawing sheet to the same size what you have the component. Okay, that is full size scale. That is the ratio, the drawn size and the actual size. If it is same, both are same, then it is the full size scale. Then the next scale is enlargement scale. The enlargement scale, you can say the example. So if you have a very small component, if you want to draw the component drawing for that. For example, suppose I have a component in my wristwatch. It is very accurately manufactured component. It is very tiny. So to that same size, if it is drawn in a drawing sheet, then it will be very small and the details cannot be read as clear. Okay. So what it will be done? To our drawing sheet, it is enlarged and it is drawn. Okay. So you can see this. So in this, this is the various components involved in wristwatch. Okay, you can see so many gears and small balls and nuts are coming inside the wristwatch. Okay, if you want to see the component drawings of this, as to the full size, if you draw it is very small, so it should be enlarged. So suppose the actual size of the say the actual size of a small gear is just in the wristwatch. If it is so actually it is 1 mm, so it is very small. So it can be enlarged to say to accommodate your drawing sheet. So if it is I'm going to enlarge, I'm going to draw that 1 mm to 100 mm in my drawing sheet. Okay, the actual size of the gear's outer dia is 1 mm. Then the ratio will be, I can say, it is 100:1. So any scale if you have, it is written 2:1, 5:1, 10:1 or 100:1, then it is the enlargement scale. So it is an enlargement scale. Another type of scale, that is a reduction scale. In reality, we can say huge components you have. Okay, we cannot able to draw the same size of that component in our drawing sheet. So what we'll be doing, we'll be reducing the size of the component and it will be drawn in the drawing sheet. Okay, that is, for that it is used reduction scales. You can see an example. So any civil engineering drawing, you can say the buildings are very huge, very large buildings. Okay, it cannot be drawn to the same size. Okay, the size is reduced and it is drawn in the drawing sheet. So you can say there is any bigger machines, in mechanical machines, you can say CNC machines or any machine tools. You can see in this example I have a machine tool, CNC machine. So the length of the CNC machine is around, it is 4,000 mm. Okay, suppose if it is 4,000 mm, it is not able to draw. The H0 size drawing sheet itself, it is maximum length is 1,189 mm. So here the size what we are going to draw is actual size is 4,000 mm. So how he can reduce it to draw it as 400 mm. So the drawn size, I am going to draw the length of the machine as 400 mm. The actual length of the machine is 4000 mm. The actual, so the ratio will be here, you can see, it will be 1:10. So 2 zeros get cancelled, 1:10. So any scale, for example, any scale, it is 1:2, 1:5, 1:10, like this, it will be a reduction scale. So for an enlargement scale, the examples I can have 2:1, 5:1, 10:2. So this is the scale. So in all your drawing, engineering drawing, the components, whatever you are drawing, below that you will be having a scale. To which scale it is drawn, it will be written. Okay, whether it is an enlargement scale or a reduction scale. So suppose if it is 1:10, I have adopted a reduction scale, right? So reduction scale. The one thing you should remember that whatever drawing you are drawing, say this is the length of this is one view of the machine. So whatever dimension you are showing inside in the drawing, the dimension should contain the actual value of the actual length of the component. Suppose it is 4000, the dimension I have to mention it as 4000 mm. Okay, but the length you have measured to draw it is only 400 mm. Is it clear? So this is about scaling, scale of engineering drawing. Okay. So throughout in your life you should remember what is scale. So how the ratio is obtained. The scale is just, it is nothing but the drawn size to an actual size. Scale is drawn size to an actual size. For any drawing you are drawing, there will be a scale will be adopted to draw that drawing. It can be a full size scale or a full size in the sense the same size it will be drawn, or an enlargement scale or a reduction scale will be adopted.